For this objective, we want to be able to find extrema on a closed interval. Extrema, what are we referring to? Here, let's take a look. So these are going to be some pre-calculus definitions, meaning that there's no derivatives and there's no limits or anything like that. And let's look. Let f, our function, be defined on an interval I containing c. This interval I, that could be anything that our function is defined on. So for example, it could be from negative infinity to positive infinity. It's defined for all real numbers. Or maybe it's part of a trig function and we only want from 0 to pi. This one in the graph is defined on a closed interval from 1 to 7. Okay, and then the c value, we're specifically talking about the x's that are down here. We're picking something in that interval from 1 to 7. So what's it mean to be an absolute maximum of this function f over the interval, in this case, from 1 to 7? So I can see that our absolute maximum here happens at 3. 3 is not the absolute maximum number. Instead, it's the y value there, which is f of 3. In this case, it's happening here at y equals 5. So what's it mean, again, to be an absolute maximum? It means that it is the largest y value for every single y value for that function over that interval. Well, it's got to be greater than or equal to all other y values. Because we did see some cases, let's say, for example, that this function continued on and then still hit the same exact y value of 5. Then I'd have two absolute maximum values. They would just be the same, and they would happen at two different x values. That can happen pretty commonly if you think of, again, the sine graph, something like that. All right, so this is what we're going to say about an absolute maximum. F of c is the maximum of f on I, our interval, if f of c is greater than or equal to f of x for all x in that interval. What's that saying? It again is saying y value. F of c is referring to a maximum y value. It is the maximum if it is greater than or equal to every other y value that occurs on that interval. All right, how about an absolute minimum? Absolute minimum for this graph, where does it happen? It happens right there. Happens at 6. Again, 6 is not the minimum value. It is f of 6, which in this case is 2. So what's it mean to be an absolute minimum on this graph, on this interval? It means that it is the smallest y value of all the y values over that interval. Well, again, it is less than or equal to all of the other y values because it's possible that it can happen more than one time. Right, so let's write something down here. F of c is the minimum of f on this interval I if f of c is less than or equal to f of x for all x in that interval. Again, it just simply means it is that y value. If you compare it to all the other y values, it is less than or equal to every other one. Another name for all of these things, so we put them all collectively, we refer to them as extrema. So we have absolute minimums, absolute maximums together, the extrema of the graph. And we also have not just the absolute ones, we also have the relative extrema or local extrema that we'll be talking about in the course of this lesson as well. Another name for absolute maximum and minimum points, here, let's zoom in right here for no apparent reason, is global. So if we take a look at example 1, locate the global minimum and maximum values of f of x shown in the graph. So once again, global means the same thing as the absolute ones that we were talking about in this previous slide. So here's our weird looking f of x function, and it's defined on this interval from a to, don't even know, whatever this value is right there. And if I wanted to locate the absolute minimum value here, just look at all the y values, and I want to see which one is the lowest one, and it looks like it occurs at a, so our absolute minimum value is f of a. Let me circle that right there. So here's our absolute minimum. All right, and then how about the absolute maximum value? So now I'm going to take a look at all of the y values and see which one is the greatest overall. This one occurs at d. So at x equals d, our f of x is at a maximum, so f of d is the absolute maximum, or the global maximum. And let's talk about where those things happen. So over here, this absolute minimum happens at an endpoint. And that can always happen. The absolute minimum and maximums can happen at the endpoints of your closed interval, and they could also happen at a turning point like this one. And specifically at this turning point, if you were to zoom in, like local linearity, what would be the slope at that particular point? It would be horizontal. I'd have a horizontal tangent line there, meaning that the slope is 0. The same thing happens over here at E, and the same thing happens over here at D. Those things, of course, are not the absolute minimum and maximum. Those are relative min and max points. But they, again, they occur at points where you have a horizontal tangent line. Oh, and then we have one final value here. What about this one? You definitely don't have a horizontal tangent line here. You don't have a tangent line there at all. In other words, the derivative wouldn't even exist there. Is it a minimum or maximum point? Well, it's definitely not an absolute minimum point, but it's still a relative minimum point because it's the lowest y value in the points that surround it on either side. So it's a relative, and it can be at a point that's let's say a sharp turn. It doesn't have to be a nice smooth turning point like this one. All right, so if we put those things together, it's going to be very important for this particular lesson. Absolute minimum and maximum, we're going to have one as long as we have ourselves a continuous function on some sort of closed interval. Where could they happen? They can happen at endpoints and at these little turning points here. And that's going to happen where we have horizontal tangent lines or we have no derivative at all.